Okay, amps are now fixed. Got a new bias pot, one new resistor for my Zobel network, and a handful of caps. Let's take a look at what's been replaced. This baggie of junk. Oh, that trash. Yuck. In the bin it goes. Okay, let's take a look at our new components here. It's getting a little grainy. Let's try to avoid that. Anyway, got some new electrolytic caps here. Nishikon Fine Gold here. Nishikon Muse there. I'm not entirely sold on audio grade capacitors, but I've got customers that swear by them and just flat out won't buy a unit without them, so I put them in. There's a coupling cap here. This has been replaced with a film instead of a low leakage electrolytic because it's even lower leakage, which gets me less DC offset. There's my new multi-turn bias pot. I can really get the bias dialed in that way. These transistors have new mica and thermal compound. The following mylar or polyester caps have been changed, which is to say all of them. Here, 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 and here. Yes, including the one that cracked open from the Zobel network. There are a couple of electrolytics that are replaced with film down there. Anywhere you can get rid of a small electrolytic and replace it with film, it's a good idea. They just last longer. If the budget allows, that's generally a good idea. And the budget does allow, because this is a fairly high-end rebuild. It's a monster receiver, so it's going to get rebuilt. Everything got cleaned. You've got new thermal compound on the bias transistor. The boards have been defluxed. The boards aren't defluxed at the factory, unfortunately, but this is Andrews Electronics, and I deflux boards because flux is nasty and sometimes it causes problems. We have new thermal compound and new mica insulators on heatsink on both units as well. I'll put that away. Let's take a look at the actual unit itself. There it is. The big beast. It's standing up right now in the service position. I'm going to rotate it around here. It's a heavy beast. I think I've been working out. It's about 40 pounds at least. I don't know if it's quite over 40 with the modules in though, but it's definitely heavy. Anyway, good, your power transformer there. There's the AM and FM tuner board there. The volume and balance pots are on that board. Various switches, including the speaker switches, are there. Meter range, high and low filter. This is the main tone board right here. And that contains several active tone controls. Well, I think they're active. It's definitely got power going to it. It may just be an extra preamplification stage, but I'm going to take that tone board out of the unit, recap it, and clean its potentiometers. Every single one of them. Every pot and every switch is getting 3-step cleaned. I flush them with isopropanol, I run a round of deoxit through them, and then I relubricate them. If you don't do it that way, you can't really guarantee that it won't get scratchy again. Up at the top there, you'll see a wafer switch. Let me unmount the camera from the tripod here, and I'll be able to show it to you a little better. Okay, this wafer switch is on the preamplification board. That's your signal input selector. Fortunately, I've got all these nice sockets here. I can just yank them off, and once I get the front panel off, I'll be able to wiggle the preamp board out. And I'm going to immersion clean that. That thing is nasty, and it's getting special attention just to keep things clean. There's the main power supply wiring. There's the main rectifier there. Got some RF suppression capacitors there. Those are the main filter caps. 15,000 microfarad, 71 volts. There's the bottom of the power supply regulator board. I'm going to talk more about that board here in just a sec. It's got some problems. Let me turn the beast over again. Hold on. It's heavy. Alright. So you can see the preamp board again. A few transistors, bunch of caps. Nothing too special. Here's the FM and AM front end. The tuning capacitor here. When you turn the dial, I'll show you what happens. It adjusts the tuning cap. That changes the capacitance, which changes the resonant frequency of the circuit. The portions with finely spaced leaves and a lot of leaves are for AM. The coarse spaced with few leaves are for FM. These are lower frequency resonant frequency, these are higher frequency. So we have 3 AM gangs, 3 capacitors ganged onto one axis, and 4 FM gangs. So tuner wise, it's a mid-end tuner, which is about all you can expect from a receiver, really. Mid-end tuners tend to go with high-end receivers. This capacitor is actually what brought my attention to the power board. Now this power board, and as far as I can tell, services pretty much anything that isn't VEE or VCC. That is, anything that isn't coming off of those big caps going to the power amplification boards. Now that cap, you'll note the label looks a little stretched past the top of the cap. You see these have a nice lip on them. This one doesn't. That tells me the bottom of that cap may be swelling, and that tells me the cap is failing. So that board's getting recapped post-haste. This is the most important board to recap besides the power amplifier boards themselves. There's the AM/FM tuner board, which you saw the underside of. I think this is probably the AM section in here, and the rest of it's FM. And this chunk here is actually FM stereo, and there's the audio output IC. And that little guy there is a JRC 4558. Probably going to replace it with a 5532 to get a little better sound quality if the customer wants something fancier. Well, they can fit the bill for it. This is the power meter board. It controls these LED meters here. There's a rather large transformer. I'm not sure of its capacity. I know it's big enough that I usually see transformers that big in 200 watt amplifiers, not 120 watt amplifiers. That board there, I don't know what it is. I'm guessing it does some speaker protection, DC detection, and emergency speaker shutoff if DC offset's found above a certain range. But there's a lot more circuitry than you would normally see with a DC detect and cut circuit. So I'm wondering if it doesn't have additional power regulation circuitry, or if this amplifier may have some extra overload protection circuitry on this board. This little guy back here has a few caps and a relay on it, and it looks like it's connected to the mains wiring, so I'm assuming this is a inrush current limiter or something of that nature. There are the big caps again, 71 volts, 15,000 microfarad each. That's actually a little on the small side for an amplifier like this. I've read some amplifier books, including a high power amplifier construction manual, which advocates 10,000 microfarad per rail per 100 watts. So by that rule, it says it should have 24,000 microfarad capacitors, but it also states you can often get away with less, but might experiment with some bigger values, especially if I have to replace those caps, because they're so big. They're 52 millimeter diameter, and they don't make 15,000 microfarad caps in 52, at least not at sane voltage ratings. It would actually be cheaper for me to put in a bigger capacitor. Of course, if I do that, I have to be wary of inrush current, and that rectifier there may not appreciate that. And if you blow up the rectifier, well, it's all over. You'll feed AC into DC circuits, and that's not good. And some antenna wiring here. Their antenna terminals are at the back here. Speaker terminals are back down there. There's the usual push spring clamp affair. The AM antennas, the mount's unfortunately broken. I'll probably have to go down to the Dallas makerspace and get something 3D printed up. Which reminds me, I should probably get a membership there. I think I'm going to be using their services quite a lot. As you can tell, I'm going to have my work cut out for me cleaning this unit. It's just really dusty. Typical Texas amplifiers, it's dusty here. Especially considering this unit came from West Texas, which is even dustier than Dallas. You can see how dirty it is. It looks bad, but I think it'll clean up really nicely, especially after I get after it with some hot water and aluminum wheel cleaner. I'll take these knobs off and soak them in that for a good hour and then hit them with a brush. It should turn out really nicely. Yeah, that's the inside of a Realistic STA-2300. The next part of this repair will be taking the front panel off, cleaning it, and servicing the preamplifier and the tone board and cleaning all the pots. Then I'll get on to the power board, recap it and check it for cold solder joints. I'll recap what I believe is the protection board and the inrush current board, and then I'll recap the FM tuner and probably find a few other miscellaneous little capacitors here. I'm basically going to hunt down every single electrolytic in the unit and change them. That's usually not required, and it probably isn't required for this unit either, but a lot of people, when they're going to spend big bucks on a stereo receiver, they want all of those wearing parts changed. And yes, an electrolytic cap is a wearing part. They wear out with heat, and they wear out with age. They have rubber seals that dry out, and when they start to dry out, they start losing electrolyte. Usually in vapor form. A lot of cases you can't even tell they're leaking, but they're actually dry inside, and that's not good. They start losing capacitance like crazy, but before they lose capacitance, the ESR, or equivalent series resistance, goes through the roof, and sometimes the leakage goes through the roof too, which is really bad. But that's about it for this unit. I'm going to tear it down completely and start the refurbishment in earnest after I put these amplifier modules back together. They just need a few screws to be put back together. But other than that, we should be good and ready to move on to the next thing.